Hey Emily, let's see if we can knock some of these questions out. So on number 16 in section 1, I believe that section 1, um, if we look at this when we're trying to find sample size. So one of the awesome things that StatCrunch does, there's many awesome things that StatCrunch does, but we're dealing with proportions, and so we have two samples, but we want to find out a sample size. And so with that, we have let's see. So we're not looking at a confidence interval. What we're looking for? Oh, we are looking for a confidence, right? So you want to be within 2 percentage points and a 99% confidence. And so when you do that, you would just put the 99, you'd put what the first proportion is, 23%, whatever it is, this one, and then, so it was 22.8 and 18.9. I'm just going to put in 23 for now. You can put in the right numbers, and 19. And whenever you do your width, so when it said within 2 percentage points, that gives you a width of 0.04. If it said within 3 percentage points, it would be 0.06 because it's 0.02 to the right, 0.02 to the left. So the width is 0.04. And then out comes your sample sizes, and it'll just give you those numbers. So that will help you with number 16A. For 16B, she does not use any prior estimate. Well, they had 0.5 in there originally, and that's always our best guess. If we know nothing about a sample and we had to guess what proportion of them participate in regular sustained physical activity, our best guess would be 50% if we didn't have any other prior estimates. So we would just use 0.5 for both of them on B. Next one you had was, if I can find it, question 2 in section 3. So let's go there. Maybe. There we go. So it was question 2 in section 3. And so in section 3 we were looking at means. I believe these were paired means, because section 2, section 2, I think, maybe section 2 were the dependent and section 3 was the independent. Looking at this one, this is totally independent. We have different sample sizes, so they are not paired up. If you're looking at your Nolan alternative hypothesis, we have population 1, population 2, test whether M1 is greater than M2, so that's always our alternative. So the only one that can be is that one. But again, your first one is always that they're equal to each other, and your alternative is based off of something in the reading, or this one just gives it to us, greater than. Then find the test statistic for the hypothesis test. Well, we just have to input our information, and where you're going to do that in section 3 is you should go to a t-stat and a 2 sample. Now in section 2 you were in paired, but these are not paired, these are independent samples, and we have a summary of the data. And so we'll just type in all our numbers, and then we should be able to change this to the same direction that we had, greater than. Type in all your numbers and it should give us the right answer. I'm not sure that they've said that we want to assume that the variances are equal to each other. And so it could be the issue of checking this box. I think I instructed previously that we should uncheck the box. And that should do it for us. Type in your information and uncheck your pooled variances. And these look a little different. M1 equals M2. If they equal to each other, if you subtract them, you'd get 0. If you subtract them, you would get greater than 0. So that should help with question 2 in section 3. And then 8 and 9 in section 4. A lot of times these are similar to each other, so let's see what we get. Leave page. So 8 and 9 in section 4. So section 4 is just kind of a little bit of everything. It kind of brings everything from 1, 2, and 3 together. So let's look at number 8. So in 1 month, the national mean price per gallon gas is that amount. The data table here represents a random sample of 20 gas stations in City A. Is gas in City A more expensive than the nation? Assume the data comes from a normal population with no outliers. So is it one population? Is it two populations? So we're comparing it to some norm, right? The national price. So in something like this would be around a single population, right? We don't have two things that we're comparing, two different samples. We have one sample compared to a population mean. And then we're probably testing the hypothesis. So again, more expensive, so is it greater than 3.07? So it looks like this would be my hypothesis statement. And then the p-value, again, once you have the data in StatCrunch, we're dealing with a one sample t-test. And we have the data. And we just have to say get the data from there, and we were comparing it to 3.107. I think we just said greater than, right? And that's going to give us our test statistic, our p-value. Our p is low, the null got to go, and so we would reject the null hypothesis. So let me check out number 9 to see if it's similar. So in 8 parts, that's a lot of parts. So if we look on the probability plot, it looks pretty linear, so we'll say close enough so we can go with our t. And so looking at them, no crazy outliers, they look pretty linear. So do the plots indicate that it is reasonable? And I'm going to say sure. They're roughly diagonal. And then we're going to be comparing these things. We could do a box plot for each one of them. So we do one for value funds. And again, once you get your data into StatCrunch, you just tell StatCrunch what to do. We can make box plots. We can do hypothesis tests. You just have to get your data in there. Oh, there we go. And so once our data is in, we can make box plots. We can compare these two means. So we'd be looking at a 2 sample. And be curious if this is a dependent or independent of 3-year rates of returns of different. So I think these are different value funds and 10 different growth funds. So these aren't related to each other. And so we'd be looking at an independent test. So let me know if that helps, and I hope you have a good day and good luck tomorrow on your final.